So just practice some of those sorts of problems just to get used to how the math goes. So how do covariance and correlation stand with each other? Your covariance and correlation are both really about how things are moving together. You can really think about your variance as being a sort of a covariance. Your covariance tells you something about how closely one variable moves with another variable. Your variance tells you how closely one variable moves with itself. It's the spread. Covariance and correlation are two different ways of trying to represent how closely two variables link to each other. There's a couple of things to be careful about. When they're positive, it means the two variables are moving together. When they're negative, it means the two variables are moving in different directions. It's always relative to the mean. So when we're calculating the variance, don't forget, we've got the mean in there. Right? We're taking how far away you move from the mean of your variable. In covariance and correlation, we've always got that mean in there again. So whenever you're talking about the variables and you're talking about movements, when you're talking about covariance and correlation, you're always saying, you know, the performance of the stock market relative to expected performance or normal performance. The performance of XYZ shares relative to expected performance of XYZ shares. Okay, so we've got correlation, positive and negative. Covariance is a number. So variance was a number, it's 357. It's percentage squared. It doesn't really mean anything. You don't typically talk about the units for variance. For standard deviation, we saw the units are percentages. Covariance is just a number. It can be big, like the 357 was for variance. Correlation is not. Correlation always lies between -1 and 1. So again, you know, keep in your head, what am I thinking about here? When you're looking at something and you're saying this is a standard deviation, it's got to be the percent. If you're looking at something and it's a covariance, it can be a number, 700, 0.2, 3,000, just like variance can. But when you got a correlation, you're saying this is my calculated correlation, it better lie between -1 and 1. So correlation is what's called normed, meaning we make sure it fits in between two boundaries, in this case -1 and +1. Make sure when you're looking at the numbers that you've written down on your answers on your piece of paper that those numbers make sense. If you're calculating, you're saying this is my correlation, it's -8, then you should say to yourself, no, I've got something wrong here. Perhaps I haven't normed it right, or maybe I've messed up one of the calculations. So covariance, like I said, is kind of like a variance. What you're calculating when you're calculating covariance, remember you're saying, if say I've got two different variables here, we're going to say it's shares in Ajax, so A, and shares in Bounce, B. So we've got two different shares, and we're going to say, well, what's the covariance between these two shares? Well, we're going to still have a sum of a bunch of different terms, so that's this sigma there, sigma S. We're going to multiply all of these calculations by the probability. So again, we're going to go back to before where we had the good, the poor, and the crisis state. So we only have 3 states to keep it nice and simple. We're going to have a covariance term calculation for each one of those states. That's what the sigma S means. We're going to have the probability P of S. So, you know, 0.5, 0.3, and 0.2 in each of our calculations. Now, what are we multiplying? So when we're doing variance before, we had the return on XYZ shares minus the expected return of XYZ shares. And then we squared them. Right? That was the variance calculation. The covariance calculation is kind of like that. It's still the return minus the expected. But in this case, we're worried about how two different variables are moving together. So what we're going to do is we're going to say, how does A do relative to its expected? And then we multiply that by how well does B do relative to B's expected. Remember in covariance, it's always relative to the expected value for that variable. How is this variable doing relative to its mean? So that's why we have the E of total return, expected total return of A in there, and the expected total return of B. And we take the difference between how A turned up, total return of A, minus its expected, and we multiply that by how well B did, total return of B, minus B's expected value. Multiply those two together and multiply that by the probability. And we sum that over each of the three states that we're thinking about. And that's going to tell us about our covariance. Remember, the covariance tells us how these two variables are moving together.